Hello students, this video is the first one to the 5-part playlist designed for the topic of Surds. Here we will try to cover the topic as per IGCSE requirements, and we will refer to the Pure Maths book from the Shingley Publications and also the student book from the Pearson. So let's get started without any delay. Now before learning what surds are, we have to learn about what rational and irrational numbers are. So a rational number is any number as written here, that a rational number is any number that can be written as a ratio or fraction. So if you have any fraction, let's say a proper fraction as in 5 by 7, it is a proper fraction. Why? Because the numerator is smaller than the denominator. So a fraction as such is called a rational number. It's a number definitely, so it's called a rational number. It has a special name. In the same manner, if we have a fraction as 7 by 5, it's an improper fraction. We all know this is also a rational number because it can be written as a fraction. If we take a mixed fraction, that will also, a mixed fraction such as 1 5 over 7. So that one will also be a rational number. 5 over 7. That is also a rational number. Now, if we take whole numbers, then let's take the number 5 or 7. We know that if we want to write it as fraction, we can write it as 5 by 1 or 7 by 1. So in the denominator, if you add 1, 1 in the denominator does not make or change any difference to the, does not make any difference or change the number. So we can say that these are the same numbers that we started with, 5 and 7. So now we can see that this can be written as a fraction. Why? Because the numerator is 5 in here, the numerator is 7 in here, the denominator is 1 in both of the cases. So this is also a fraction, and hence 5 and 7 are called rational numbers. But what if we have a decimal, 0.25? Now we know that 0.25 can be written as 1 by 4. If you are unsure, then you can always use your calculator to check. You will have your calculators at hand. So we know that when we input 0.25 in the calculator is designed to give us all answers in the decimal, all answers in the fractions. So we get 1 by 4 as the answer. And we can see that 1 is the numerator in here, 4 is the denominator. So we can definitely say that this is a rational number also. If you take 1.25 again, you will get 5 by 4. So we can say 5 by 4 again is a fraction with 5 in the numerator, 4 in the denominator. So all of these are examples of rational numbers. Why? Because these all can be written as ratios. So rational, as the name suggests, has a ratio in the front. So we can say that these are all rational numbers. But what if we have a decimal number which doesn't end up, very big decimal number, or a number such as pi? See, pi, if you give in your calculator, you will get 3.14, and then there comes a very big number, right? 3.14 and a very big number with a never-ending decimal. So we can say that this pi is not a rational number, because if it was a rational number, then definitely it would have been given in the calculator as a fraction, but it is not. We learned in the childhood in class 6 or 7 that 22 by 7 is an estimate of pi, right? When we give 22 by 7, we get an estimate which is 3.142857. And if you see, this number is somewhat close to pi, but it is not exactly the same number. If you continue on with the decimals, you will see that the value of pi in the long run is very different from 22 by 7. When we used 22 by 7, it was just an estimate. So 22 by 7 itself is a rational number, but pi is not a rational number. Similarly, if you put root 3 or root 7 in the calculator, you will see that you get decimal answers. So these are also not rational numbers. But if you put root 4 or root 9 in the calculator, you will see that root 4 gives you 2. And we know 2 can be written as 2 by 1. And root 9 can be written as 3 by 1. So we can say that these are definitely fractions. So these are rational numbers. So all roots are not irrational numbers. Only roots of numbers which cannot be written as a fraction is called an irrational number. And these kinds of irrational numbers, these kinds of special roots are called surds. These special roots are called surds. Now for IGCSE from surds, we have two topics in particular. The first one is the simplification and the second one is the rationalization. Now, for both simplification and rationalization, we need to know some formula. And these formula we have already seen in earlier classes. But let's just see these so that we remember them in the simplification. Now, A, B, M, N, all of these here are numbers. These are representation of numbers. These are instead of formula in here, so that you do not confuse them with the sums. We always remember formula in pure maths as letters in here, or variables we can say. So A and B here, let's say instead of root A and root B, we have root 3 and root 5. So for the first formula, we have root 3 plus root 5. So if you put root 3 plus root 5 in the calculator, you will see that the calculator gives you 3.968, a number as such, 3.968. And on the other side of the equation, we have root A plus B. So root over 3 plus 5. Now root over 3 plus 5 is going to give you root over 8. Right? 3 plus 5 is 8. So root over 8 from your calculator is 2.828. 2.828. Now 2.828 and 3.968. Definitely these two are not the same numbers. So we can say that these two are not equal to. This special symbol in here means not equals to. You give an equal to sign and then you cross it out from the middle. It means it is not equal to, which means that you cannot say or you cannot add these two roots. For addition or multiplication of roots, the simple formula or the simple technique to remember is that for addition or subtraction of roots, you work with the same type of roots. But for multiplication and division, you do not have any multiplication and division. You do not have any such rule. You can work with all type of roots. Okay. Now see here. If you cannot add, then you cannot subtract the roots as well. And this also can be checked with root 3 and root 5. If you subtract root 3 and root 5, what do you get? You will see that you get a negative number which is minus 0.504, something like this. But if you put root over 3 minus 5, you get minus root over 2. Now negative number cannot be made into a square root. So the calculator does not give you an answer of. So this is definitely not possible. But from here, you get an answer. So which means certainly these two are not the same thing. But for multiplication or division, see, if you have two separate roots, root A and root B multiplied, you can definitely multiply them. And as an example of this one, you can again take the examples of our old friends root 3 and root 5. So if you multiply root 3 and root 5 from your calculator, see, you are going to get, the calculator directly gives you root 15, or if you put in the decimal, you get 3.87 something. And on the other side of the equal to, you have root over a and b. So root over a and b is root over 3 into 5, which is 15. So you don't even need to check the decimal. You see root 15 is here as well, root 15 is here as well. So definitely this one works. In a similar manner, you can try out with root 3 and root 5 the same example in here, and you will see that this formula holds. In the same way, for m and n, you can take the value of m as, let's say, 2 and n as 4. It will also work with any other number. If you want, you can take 12 and 14, or 21 and 41, or 43, any number you want if you take any numbers in here, or even fractions like 2 by 5 and 3 by 5, or 3 by 8 if you wish. You will see that this one holds. And the same goes for this one. Now, for addition and subtraction, here you have m and n as two separate numbers. Now you have, so as I was telling earlier, that let's take the value of m to be 2 and n to be 4. Then you have 2 root a and 4 root a. So you have 2 roots of a and 4 roots of a, which makes it the 6 roots of a, right? So it can be thought of also as, you have 2 pens and 4 pens. So when you add them up, you have a total of 6 pens, right? And how did you find that one out? You added 2 and 4 in here. So we did the same thing in here. This is 2, this is 4. When we add this, we get 6 roots of a. So in the same way, you can prove the subtraction one. And now in the last, we have a very special formula. A very special formula in the sense that now we have the multiplication of two of the same thing. So we have root a into root over a. And we know for multiplication, the rule of multiplication holds for any kinds of surds. So we can definitely multiply the same kinds as well. So we get root over a square as mentioned in here. Now we know that the square and the square roots are opposite operations. Square and the square roots are opposite operations, just like addition and subtraction, multiplication and division. One undoes the other one. So square and root, they cancel each other out, or they neutralize each other out. So the square and the square roots, they get cancelled out, and we are only left with the a in here, which we have given in here. So if you multiply the same type of number twice, you get the same type of number as roots twice, then you get the number itself. So if you multiply root a and root a, you get a. Another approach to this one is, you can also say you have root a into root a. So you have root a squared, because root a is multiplied twice. So the square and the root again cancels out, and you are left with a. So with this, we are done with understanding all of the formula for surds, which we will be needing in the future videos. In the future lectures, we will be needing all of this. And in the next one, we will be learning about the simplification of surds, where we will be given certain surds and we will try to simplify them as much as possible. See you in the next one.